All right, so welcome. So we're still on this table. In the first video, we were able to fill up the first row. Okay, so in this video, we're going to try to see as much as we can to fill up the second row. Okay, so the property that was given to us here include we have mass. The mass here is 2 kg, so the mass is known. M equals 2 kg. Okay, we have pressure. Pressure was given to us here as well as simply 34 bar. So pressure P is simply 34 bar. Okay, what else was given? We were given dryness fraction. Okay, for this particular row or column, we're given dryness fraction X. Okay, so dryness fraction dF simply X is equal to 0.9. So we have this. What else? Okay, that's also where to fill temperature, volume, degree of superheat, enthalpy, and internal energy. Okay, let's do this now and see. Alright, so to find the saturation temperature, of course, it has to correspond to this given pressure. So we check from saturated water and steam. Okay, from saturated water and steam. Okay, corresponding to the given pressure, and the pressure that is given to us here is simply 34 bar, corresponding to 34 bar. Okay, the temperature there is called saturation temperature, and the value is simple. Let's get this thing table now. Okay, so saturated water and steam. Okay, we're there, so we look for 34 bar. This is column for pressure, 34 bar. Okay, so this is 34. All right, so this is 34 bar. This is 34 bar. Okay, this is the temperature there, which is 240.9. That's the saturation temperature there, 240.9. All right, so it means temperature there is simply 240.9. All right, so we'll have a saturation temperature that will be 240.9 degrees Celsius. Okay, so that is that for that column. So temperature there is 240.9. So we'll fill that up. All right, next up is to find the volume, and recall we said total volume is simply mass times dryness fraction times volume at the gas at that given pressure. Okay, so from saturated water and steam corresponding to 34 bar, we are still going to obtain the value of Vg there at 34 bar. So we'll look up the steam table now. This is 34 bar. Let me pull it up a bit. Okay, so we'll have 34 bar here. And we are looking for volume at the gas is 34 bar. This volume at the gas 0.05875. Let's get that and see. Of course, yeah, that's Vg. That's volume at the gas 0.05875. Okay. So we have Vg to be 0.05875. That's meter cube per kilograms. Okay, so this simply implies now that volume is now equal to mass. The mass was given to us as simply 2 kg. The mass is 2 kg, so we simply have mass, which is 2, multiplied by dryness fraction was also given, df, that's 0.9, multiply 0.9, multiplies Vg, which we just obtained as 0.05875. Okay, so this simply implies that total volume V is equal to, okay, that's approximately 0.11 meters cube. So that becomes the volume. Okay, we know the volume now, so fill up backspace 0.11. Next up is to find degree of superheat, and we can't find degree of superheat without knowing enthalpy or internal energy. So which means we have to move ahead to find internal energy and enthalpy. Okay, let's start with enthalpy. Okay, so recall the relationship between dryness fraction X to enthalpy is simply specific enthalpy minus enthalpy at the fluid all over enthalpy to the fluid and the gas HFG. So we'll have this. So we know this. Let's make enthalpy subject now. So if we make specific enthalpy subject, we are simply going to obtain HF plus X HF G. So we are going to have this, okay. This, so all we need to do now is still from saturated water and steam corresponding to 34 bar. We need to find the value of HF and HFG. So at 34 bar, from saturated water and steam. Alright, so we'll obtain what HF is and what HFG is, and that's okay. Alright, so I'm gonna zoom this a bit. Alright, so once again, this is 34 bar. Alright, it's 34 bar. Okay, so this should be HF. Let's see. Yes, that's HF, and the middle is HFG. So HF is simply 1042 and HFG 1761. Okay, so HF is simply 1042. We have HF to be 1042 kilojoules per kilogram. HFG 1761 kilojoules per kilogram. Okay, we'll have this. So having known this now, it becomes easier for us to find H, specific enthalpy. So H is equal to, so we said what, HF, and HF simply gave us 1042. So we'll put that down, 1042 plus next is what, X. X is dryness fraction, and we obtained dryness fraction. It was given as 0.9. So that's simply what, 0.9 multiplying by HFG. Okay, HFG here, and HFG simply 1761. Okay. Specific enthalpy is simply 1042 plus, so 0.91 multiplies 0.9 multiplies 1761. Alright, so we have 1584.9. Okay, so we can add these two together. Alright, so plus 1042. So that simply gives us 2626.9. So it means specific enthalpy H. This implies that H is simply 2626.9. This in kilojoules per kilograms. Of course, we have the mass, so we can find total enthalpy simply by multiplying this value by mass. And mass was given as simply what, 2 kg. So we simply have 2 times 2626.9. This simply implies that total enthalpy is now equal to, that gives us 5253.8 kilojoules. Alright, so that becomes the enthalpy. Let's fill up that spot. 5253.8, 5253.8. Finally, let's find the internal energy. Okay, internal energy. Alright, so we know the relationship between, it's still the same formula. Only thing that changes is the thermodynamic property. Same thing here. X, okay, is simply equal to specific internal energy minus internal energy of the fluid all over UFG. Okay, so we can simply make specific internal energy subject. So we're going to obtain that U is actually equal to UF plus X UFG. So it's basically the same formula. It can be seen here. The only thing that changes is what, the thermodynamic property. So still from saturated water and steam. Okay, water and steam corresponding to the given pressure, which is 34 bar. We have to obtain what UF is and UFG. Okay, UF. Let's check that now. Alright, let me zoom this a bit. Alright, okay, so 34 bar, which is here. Okay, which is here. This is the UF column. UF is simply 1034. Let's confirm. That's UF. Yep, 1034. That's UF, right? Okay. So we have that to be 1038. And this is UG 26062603. That's UG. Okay, so that's UG. Alright, so let's get that back now. UF is 1038, UG is 2603. Okay, so UF is 1038. UF is simply 1038 kilojoules per kilograms, and UG itself is simply 2603 kilojoules per kilogram. So we have this. Okay, having known this now, of course, I said you can find UFG, and that's simply UG minus UF. Okay, so UFG is equal to UG is 2603 minus UF is simply 1038. So that simply means UFG is equal to 1565 kilojoules per kilograms. Okay, so if we have this, we can now substitute into this equation to obtain the internal energy, specific internal energy. So U is now equal to, okay, we said here UF, so UF here is simply 1038, so simply have 1038 plus, next is Dryness fraction, which is X, and Dryness fraction was given as 0.9, so we have 0.9 multiplied by UFG, and UFG is simply 1565. Okay, so U is now equal to 1038 plus 0.9 times 1565. Okay, we have 1408.5. Okay, so we'll add this up with 1038. So this implies specific internal energy U is equal to, we have 2446.5 kilojoules per kilogram. So also we have to convert to total internal energy. That's simply mass times specific internal energy. Mass is given as 2. Okay, so 2 by 2446.5. This implies that internal energy itself is equal to, so we'll simply have 4893 kilojoules. So this becomes the total internal energy. Okay, so we'll replace that here. Okay, 4893. Alright, so 4893. Alright, so that gives us total internal energy. Now we're left with finding the degree of superheat. Okay, and as you all know, degree of superheat is simply superheated temperature minus saturation temperature. Okay, we already found the saturation temperature and that given pressure. Okay, so we obtain that temperature to be simply 240.9 degrees Celsius. So saturation temperature already, this saturation 240.9 degrees Celsius. So let's find the superheated temperature. So we'll use any of between the internal energy or the enthalpy, specific internal energy or specific enthalpy. Okay, so let's use specific internal energy. Specific internal energy simply give us 2446.5. Okay, so we'll look at superheated steam table corresponding to this specific internal energy 2446.5. You may also wish to use specific enthalpy. You will see obtain the same results. Okay, we obtain specific enthalpy to be this 2626.9. You will still obtain the same result. So from superheated steam, okay, from superheated steam, corresponding to that and internal energy corresponding to U equals 2446.5, corresponding to U equal 2446.5 kilojoules per kilograms. Okay, once again we're using specific properties simply because we're using specific internal energy simply because the properties of the steam table are all specific properties, so we don't use the total internal energy. So we look up the superheated steam table now to obtain our given superheated temperature. So from superheated steam, okay, once again these are the values for internal energy. This internal energy, which is the second value. Okay, so we're looking for 2446.5, and this is line for 23. We don't need here. Okay, so there's 24 here, 2446. Okay, all right, so this is 2446. Okay, and here we're looking for 2446.5. Okay, so it's obvious that 2446.5 actually lies between this and this. Okay, so it lies between this 2446. All right, so given internal energies we've obtained so far, let's bring it out. Okay, we have 2446. We are looking for 2446.5, so it lies between that 2446 and 2517, and the temperatures are simply 10 and 100. So 2517. So okay, 2517. Temperatures are giving us this is 10 degrees. This is what we're looking for, T superheated, and this is giving us 100 degrees. Okay, so as usual, we interpolating. Okay, if we interpolate this, like I said, use the bottom to subtract all, send energy at this other side. So we use here 2517 minus, okay, top here 2446. It also means I'm going to maintain the same energy here. It has to be 100 minus 10. So I simply have 100 minus 10. Okay, all over next is 2517 subtracting this. So we have 2517 subtracting 2446.5. Okay, and okay, sorry. All right, all over it has to be the 100 minus T superheated, what we're looking for. So it becomes 100 minus T superheated. So from here, 2517 minus 2446. Okay, that gives us 71 all over 2517 minus 2446.5. That gives us 70.5. This is now equal to, here we have 100 minus 10, which is simply 90 all over 100 minus T superheated. Okay, so we can divide this. 71 divide 70.5. I would prefer to do that. That simply gives us 1. Okay, we'll have that to be approximately 1.007. Okay, and that's equal to, we'll have here 90 all over 100 minus T superheated. So I said this is simple as saying 1.007 divided by 1, so it becomes easier to cross multiply. 1 multiplies 90, this multiplies the whole of this value. So I simply have here 1 by 90, and that's equal to 1.007 multiplying by 100 minus T superheated. Okay, that simply gives me 90 equals 100.7 minus 1.007 T superheated. Okay, so from here I can send 100.7 over here. I simply have 90. Of course, positive cross and equal to sign becomes negative, minus 100.7, and this is simply equal to minus 1.007 T superheated. And of course, 90 minus this simply gives us minus 10.7 equals minus 1.007 T superheated. So we can now make T superheated subject simply by dividing both sides by minus 1.007. So I have minus 10.7 divided minus 1.007. So this simply implies that superheated temperature is simply equal to, that simply gives us 10.62 degrees Celsius. So we have this will be superheated temperature. Therefore, degree of superheat once again is negative. Is simply, we said, superheated temperature minus saturation temperature. Once again is negative. Okay, so we simply have 10.62 minus, of course, we obtain saturation temperature as 240.9, so minus 240.9. This simply implies that degree of superheat is equal to, simply minus 230.28 degrees Celsius. Okay, so like I said, the steam is more saturated than it is superheated, so I guess that's why we'll keep on having negative values. Alright, so let's reflect that on the table. So we obtain minus 230.28. So we have minus 230.28. Alright guys, as in the case, as in the first case, the table is just like in the first case, the video is getting longer than expected. So I'll pause the video here and I will do another video for the third row. Okay.